Hello everybody, it's Tuesday night or Wednesday morning, depending when you get this. I just want to do a couple of things before we start into a new class today. We had our live class this morning. Some of you were there, but half the class was there. And if you were there and you want to see the recorded session that we did this morning, you can always go back to it. And we have our next live class on Thursday this week. And I've added a button to our main taskbar toolbar here, which is our live class button right here. If you want to get into the live class, which is in Microsoft Teams, you can see it up there. You just have to tap on that. I'm not going to do it now because I already recorded this video once, and when I clicked on Teams, it cut off my video because it hijacks the camera for Microsoft Teams. So I'm not going to do that, but you'll see if you click on the Teams button up there, this one here, click on the Microsoft Teams, and then you'll see a button that says Join Class in the middle of the screen, and then up in the top right corner, you'll see a button that looks like a dialog box. That's that little thing. It looks like what somebody is saying when they're talking in a cartoon. It looks like a bit of a cloud above a person. So the dialog box, if you click on that, you will see today's recorded class. If you just want to get into the next class on Thursday morning, just click on the live class and we'll open it up for you, and you can actually go in to the live class directly from there without having to use a join button in the announcement. And I'm going to head towards that too. So this new button up here is for joining live classes, and it's for accessing past recorded sessions from past classes. All right. While I've got you here, let's have a quick look at our calendar. In the calendar, I'm seeing that we are here with our live class today, that tomorrow we're going to be doing probably the biggest note of the year. The biggest question of the year. The video was tonight for it, so you'll be doing this tomorrow. That's a big one. I'm going to do a live class on Thursday again to work through some of these questions. We're going to finish our test here on Friday, or finish our Chapter 6 on Friday, which means we'll be ready for a test next week. So here we are. Friday will be our note for our last note, like I just said a moment ago. And then from there, we will have our STSE for Unit 3 due here. We'll probably have a review class, and I'd say by the 6th, we're probably ready for a test for Chapter 6. So I'm going to post that up there. After that, we're going to change gears completely, get out of all this mole stuff, out of all the calculations. We're going to move to electrochemistry, which is a very, very different type of chemistry than we've been doing, but a very important part of chemistry. I haven't decided yet. I may move into organic chemistry next, but I think I'm gonna jump into electrochemistry. Okay, so let's pick up where we left off with the class this morning. If we look at the work from the note here the other day, I left you with these questions of the 6.3, 6.4 note. Right, I left you with these questions here, and today I suggested that you try these questions here. And before I jump into our new note, you can't do this really unless you can do this. So if you haven't done these questions yet, I'm going to suggest you go back and try them. I'm going to do question 8 from this set before I go any further, and then we will get into new stuff for today. So if I start with question 8, this is question 8 here from the textbook. I'm going to read the question to you. Question 8 says, acetylene, C2H2, is a gas used in welding. So here's the gas right here that's used in welding, C2H2. It says calcium carbide reacts completely with water. How much acetylene are we going to be producing if we know we have 2.34 times 10 to the third grams of calcium carbide? So similar to the questions we did today, just to look at our strategy, we know the mass of this reactant. I'm going to use that to calculate the number of moles of calcium carbide using N equals M over M. Then I'm going to use mole ratios to calculate the number of moles of C2H2, mole ratios. And then I'm going to use the little n to calculate my unknown mass using mass equals number of moles times molar mass. Okay, so all these questions are the same. If you're looking at this maybe for the first time and saying, okay, what about water? There's no mention of water anywhere in this question. There's no mention of calcium hydroxide anywhere in this question. And the answer is they're there. They're part of the reaction, but I really don't care about them, right? And you think, well, that's not very, that doesn't sound like a good approach. If you're going to be mixing chemicals, to ignore some of the chemicals. You'll see when we get into tomorrow's note, or into the next note that I'm going to be doing in a minute, why I can ignore some of the chemicals, right? Because some of them, there's just way more than I need, and I only have a certain amount of some chemical, and it's going to be the one that decides how much product I'm going to get. Okay, so let's go back here, and we will pick up where we left off. Okay, so there's the question. Calcium carbide, CaC2, reacting with two waters to make calcium hydroxide plus acetylene, C2H2. Now, when we're doing this, when I did the questions today, we started by calculating our molar mass. Right, the molar mass is 1 calcium plus 2 carbons, so the molar mass is 64.10 grams per mole. And the molar mass over here for calcium, for acetylene, is going to be 26.04 grams per mole. Okay, so those are my two molar masses. Notice that I'm not putting anything underwater. I'm not putting anything under the calcium hydroxide in this equation. I'm working in the space under calcium carbide here, specifically, and I'm working in the space under acetylene here, because I need this math and this math to solve for my final answer. So I'm going to basically ignore all the space in the middle here, because it really has nothing to do with what we're doing in this question. So, first step, calculate the number of moles of what I know on this side, because I know the mass and I know the molar mass. I can calculate the number of moles. I've got 2.34 times 10 to the power of 3 grams divided by my molar mass of 64.10 grams per mole, right? Mass divided by molar mass, and I'm going to get a number of moles, which is 936.5 moles. Okay. Once I know the number of moles on this side, I can use my mole ratio to determine my number of moles over here. So to calculate my number of moles of C2H2, right, of acetylene, this one here, right, and I need to know that because to find the mass on this side, I need the number of moles times the molar mass. Molar mass is easy, right off the periodic table. Number of moles I've got to calculate. So if I know the number of, to determine the number of moles of C2H2 here, I'm going to start with the number of moles of what I know, which is calcium carbide, times the mole ratio. Mole ratio now is going to use the coefficients from the balanced equation. And I'm going to start, I'm trying to get rid of this calcium carbide because I'm trying to solve for C2H2. So I'm going to put the number of moles of C2H2, which is 1. I've got 1 C2H2 up in my balanced equation. And the number of moles of calcium carbide, you see there's a 1 here for calcium carbide. Right, so when I'm done, I've got my number of moles, which was 36.5, right, from here, number of moles of calcium carbide, times 1 over 1, right, which is equal to 36.5 moles of acetylene, C2H2. Notice that the calcium carbide in the numerator and the calcium carbide in the denominator disappeared, and I'm left with an answer which is in moles of acetylene, right, down here, moles of acetylene. So now I know my number of moles of acetylene, again, let me just scroll up here a little bit. Right now I know for acetylene, I know the number of moles. It is 36.5. So now I can calculate my mass, which is number of moles, 36.5. I haven't given myself much room here. I wonder if I can slide this over. No, I can't. 36.5 times my molar mass of 26.04. And I get a final answer of 951 grams. That's my final answer. So if I look at my original question said if I start with this many grams of calcium carbide, how many grams of product am I going to get, of C2H2 am I going to get? Start with your mass, calculate your number of moles, use the mole ratio to determine the N on this side, use the N on this side to determine the mass on this side. Right, 951 grams. Okay, from there I want to move into today's note. Okay, so hopefully you've had a chance to try these questions here before starting today's class. All right. Today we're going to talk about what happens when I'm mixing two reagents together and using both of them to decide how much product I'm going to get. Now, in an earlier question back in 6.3, we looked at what happens when a nitrogen reacts with 3 hydrogens to make 2 nitrogen trihydrides, or ammonia. That's ammonia. NH3 is ammonia. It's like H2O is water. So N2 plus 3 hydrogen gases makes 2 nitrogen trihydrides. From that equation, I now know that if I have 1 molecule of N2 and 3 molecules of H2, I will get 2 molecules of two NH3s. And that the 2 nitrogen atoms I have over here are embedded in here in the 2 NH3s. And that the 6 hydrogens that I had over here, they're also buried in the 2 NH3s. So all the atoms that I started with are accounted for at the end. Now, the question says, if we add another N2, so let's add another N2 to this side. Oops, let's not put 2 there. If I added a second N2, so I've got 2 N2s on the left and 3 H2s and 2 NH3s, recognize what's going to happen. These 2 nitrogens here are going to react with these 3 hydrogens here to make my 2 NH3s. This nitrogen here has got nothing to react with because these 3 are already gone. They were used by this to make this. So when all is said and done, I will end up with 2 NH3s and I'll have an N2 left over because I put it in and it wasn't needed. That chemical that was added is called an excess reagent, right? It's extra. There's more of it than I need. So so the nitrogen here, if I add the extra nitrogen, right, the nitrogen is now an excess reagent, which means there's more than I need. And what that means is there will be some left over at the end. What about the hydrogen? The hydrogen here, well, I had 3 there. I had 3 of them here, and they all reacted, and they're all gone now. Right? They're the ones that were important because they decided how much NH3 I could make. I could add another N2 and another N2 and another N2, but if I've only got 3 H2s, I can only make 2 NH3s. So the one that's going to run out, right, it sets the limit. It's called the limiting reagent, right, and it's the one that decides how much product can be made, right, because it's going to run out. Right? So in this case, hydrogen is the limiting reagent, And with all that extra nitrogen in my system, nitrogen is the excess reagent. What if I did it the other way around? What if I took, instead of having N2 plus 3 H2s to make 2 NH3s, if I throw in an extra H2, an extra H2 here. So now I have 4 H2s, right? So I've added an extra H2. So now I have 4 H2s, right? Notice what's going to happen. The 2 nitrogens that are here will react with the 3 H2s to make my 2 NH3s. All the atoms are accounted for, and the extra H2 that I added to the system, had nothing to react with. So at the end of the reaction, it's going to be left sitting there unreacted. It was excess. It was more than I needed. The one that ran out, in this case, was the nitrogen. All the 2 nitrogen atoms disappeared, and what was left over were some extra H2s. So in this case, now nitrogen becomes the limiting reagent because it's the one that's going to run out. Right? Nitrogen will run out, and the one that's excess is the one that will be left over at the end of the reaction. Okay, so there's 2 important kind of messages here. Number 1, I need to determine which is the limiting reactant or limiting reagent. Right? The limiting one is the one that's going to decide how much product I can make. Right? The amount of product is determined by how much limiting reactant there is. The one that's there in excess will be left over. Okay, so to do this question now, I'm going to follow a very similar process to what I did before. There's a question here when I did this sample problem an hour ago and it didn't record. I did the sample that's here, but I'm not necessarily that happy with it, so I'm going to start with a different one. Okay, I'm going to start with a reaction that is, there's 6 steps to doing this question, and I'm going to walk you through the 6 steps. So let's go to the whiteboard, and I'm going to write down the reaction that I'm going to do right now, which is the reaction of aluminum with oxygen to make aluminum oxide. Oops. Okay, so I'm going to look at, aluminum reacting with oxygen to make, I'm going to make this a bit bigger, to make aluminum oxide. Okay, so there's the chemical reaction that I am looking at. Aluminum reacting with oxygen gas to make Al, Al2O3. Okay, so the question says, if we start with 134.9 grams of aluminum and 96 grams of oxygen, how much aluminum oxide am I going to make? Al2O3. Right? How much aluminum oxide am I going to make? So, to do this, I've got to first decide which of the 2 reactants that I've put into my system, the aluminum or the oxygen, which of these 2 is going to be excess and which one is limiting, which one's going to run out first. So I'm going to do this in stages. So let's go back to our 6 steps in the note. Step number 1 says write the balanced equation for the reaction. Okay, so we've balanced that equation. I didn't walk you through it, but I did actually balance it. 4 aluminums on both sides, 6 oxygens on both sides. Step number 2, calculate the molar mass for all of the compounds, the reactants and the products. Okay, so let's go back to here, and I'm going to put in my molar masses. From the periodic table, the molar mass for aluminum is 26.98 grams per mole. And the molar mass for oxygen is 2 times oxygen, 2 16s, which is 32.00 grams per mole. Okay, so I've calculated my molar masses for those two, and I need the molar mass for my aluminum oxide. So my molar mass here is 2 aluminums and 3 oxygens. When I add them all together, I get 101.96 grams per mole. Okay, so I've determined my molar mass for each reactant and for the products. Okay, step 3, calculate the number of moles. For both reactants. Okay, so let's go back to my question. And I'm going to calculate the number of moles of aluminum and the number of moles of oxygen. Now, number of moles is mass, 134.9 divided by my molar mass, 26.98. And over here, my number of moles is equal to the mass, 96.0 grams, divided by the molar mass, 32.00 grams per mole. And on this side, I'm getting a number of moles of 4.97. And on this side, I'm getting a number of moles of 3.00 moles. Okay, so I've calculated the number of moles for both reactants. Okay, so that's step 3. So I wrote my balanced equation, I calculated the molar masses, and I've calculated the number of moles of each reactant. Okay, step 4, right, it says divide the moles of each by the coefficient that's in the balanced equation. Okay, so let's see here. Let's scroll this up a little bit. I'm going to make it a bit smaller. Okay, before I do this step, you might have seen in the question, in my steps, that I actually had a line drawn across between step 3 and step 4, and between step 4 and step 5. So step 4 is kind of blocked from the question by a solid line. So I'm going to go back to my question here, and I'm going to draw a line across here. And it said divide the number of moles by the coefficient in the balanced equation. The coefficient here is 4. And I'm getting 1.24. I'm going to do the same thing here. I'm going to take my number of moles, from here, divided by my coefficient, which is 3. Okay, so I now have 1.24 on this side and 1.00 on this side. Okay, the note tells me that the lower number of the two is the limiting reagent. The higher number is the excess reagent, which means some's going to be left over. Now remember what I said a minute ago, the one that's limiting here is the one that determines how much product I'm going to get, because it will run out first. When it runs out, I can't make any more product. Right? So all the way back here, the amount of product is determined by the limiting reactant. Right? So step 4 says decide which is limiting by looking at the lower number. The lower number here is this one. Okay, that's my lower number. So what that tells me is that this one is limiting. Get rid of that. This one here is limiting. And this one here is in excess. Because the one on the left is in excess, right, I really don't need any of the math from this side, because everything that's on this side is irrelevant now. The one that's important for doing the rest of the question is the one that decides how much product I can get, which in this case is the oxygen gas. Right? It is the 3 O2s that decide how much product I'm going to be able to make. So step 4, which is inside this line here, said I need to look for the smaller number. To take the number of moles divided by the coefficient 3. Take the number of moles divided by the coefficient 4. And then I end up with the two numbers, and I look for the lower one. The one that's the higher one I don't care about, it's the lower one. The one that's going to run out is the important one. The other one's a high one, I don't need it. So now I can calculate. Now I know N here for oxygen. I can use this N to calculate little n for the aluminum oxide. Once I know the little n for the aluminum oxide, I can find the mass here, which is what my unknown is. Right? Unknown is how much aluminum oxide, by taking the n times the molar mass. I know the molar mass, we already calculated it. So all I need to finish this question now is what is little n here? Right? What is this little n? So to find that little n, I need to use my mole ratios. So mole ratios say the number of moles of aluminum oxide are equal to the number of moles of my limiting reagent, which is oxygen, times the ratio of their moles in the balanced equation. So I'm going to have oxygen in the denominator and aluminum oxide in the numerator, because I want the oxygen here to cancel with the oxygen here, and I want this aluminum oxide to be left so that I can have the answer for number of moles of aluminum oxide. So if I go back to my balanced equation, I'm looking for the coefficient for aluminum oxide and the one for oxygen. Aluminum oxide is 2, oxygen is 3. Aluminum oxide was 2, oxygen was 3. So let's do our math now. Our number of moles of O2 was 3 moles. Right? That's our number of moles of O2. Come on. 3 moles of O2 times my ratio of 2 over 3, and I get a number of moles of aluminum oxide, which is 2 moles. Now I can take this number up over there, and I can solve for my mass. The number of moles of aluminum oxide is 2.00 moles. And now I can calculate my mass, which is number of moles, 2, times molar mass, 101.96. And after all that math, I come up with the answer I was looking for up here, which is how many grams of this am I going to get if I react 96 grams of oxygen with 134.9 grams of aluminum. Now, if I was thinking, what am I going to have left over when all is said and done at the end of the reaction? I will have 204 grams of aluminum oxide, and I will have some of this aluminum left over because it was excess. This will all be gone because I used it all up when I reacted it with some of the aluminum, and now there's more aluminum than I needed because it was in excess, and I ignored it. Right? So I usually put a squiggly line, not so dark that I can't see what the math was, because sometimes I might need to go back and look for something, but usually I put a squiggly line through the one that's in excess so that I can know that I'm ignoring that side, and now I can just work on the limiting. Notice my strategy again, right? Doing all the math for aluminum under aluminum, all the math for oxygen under the O2, and then all the math of the aluminum oxide here, with the exception of my calculating of the number of moles using the mole ratios. Again, if I had lots of room, I would have done all this math over here under the aluminum oxide, right? But I didn't have that much math, that much space. Okay, so back to our note. Step 5, use the ratios to determine the number of moles. Mole ratios to find the number of moles of products. And then calculate the mass of your product, right, the way we just did. Okay, 6 steps. Every single time, always the same. So I can't make this hard, difficult, tricky, because every question is identical. Right? You follow the same 6 steps every time, and it always works. Now I've got a sheet that I'm going to look for. I'm going to add it to the hub in Mr. Sinha's notes and stuff for unit. What unit are we in here? We're in unit 3, chemical calculations, and it will be a worksheet, and it's got these 6 steps on it, and I encourage you to keep it handy. Again, if you were at school, I would have handed a printed copy to you to use, but any way that you can either put it somewhere or print it or do something with it so it's always handy, so you've got your 6 steps there. I would suggest once you've done a few of these questions, you probably won't need this anymore. Now, there's another sample problem. I think, like I said, I did this one earlier and I really didn't like it. This is the one that I just did now, right? This sample, the answer was 204 grams of aluminum oxide. So I'm going to leave you with the 2 questions here on page 223, and there's 2 more questions on page 225. And when I come back to do our live class on Thursday, I will take up probably 2 of those 4 questions. You can let me know if there's 1 or 2 that you have trouble with, and we'll go from there. All right, so I hope everything is well. We're at the apex of this course, I think. From here on in, I think things get a lot easier. So if you're looking at this thinking, I give up, right? I just quit, I give up, this is too much, recognize things are going to get a lot gentler after this. For those of you who have been really keeping up and are kind of following through and everything has been clicking, hopefully this should click very well for you. If you haven't been, try your best to see if you can't make some of these questions work from 6.